Now that you know more about Redis Pi, let's use it to run some basic Redis operations. First, we'll see how Redis data structures map to Python types, and then we'll look at some examples from the course project. Redis Pi maps Redis data structures to their equivalent Python types. You probably remember from our discussion of string encodings that Redis Pi can map Redis strings to Python bytes objects or string objects. Now let's talk about a few of the other Redis types. Redis lists become Python lists. Likewise, Redis sets translate to Python sets. And with hashes, you get Python dictionaries. Now, in most of these cases, the values you get back are bytes objects or string objects, depending on the argument you give for the decode responses parameter on the client instance. However, when you run a command that returns floats, like anchor by float, you'll get back a Python float. To illustrate this, I've put together some examples of basic Redis commands run using Redis Pi. You can see these in the test redis basics.py file. I start out by creating a list of planet names. Notice that I've repeated a couple of planet names twice, Mercury and Earth. I've also included the dwarf planet Pluto. That gives us a list of 11 planet names. So, now take a look at the test redis list method. First, we assert that the planets list is 11 elements in length. Next, we push these planet names onto a Redis list called, appropriately, planets. The return value is an integer that indicates the number of items we added to the list. And here we assert that Redis added all 11 items. Now it's time to return the entire list, so we use the lrange command. This gets us a list of strings. And here we assert that the Redis list of planets matches our original list. Now, to remove the duplicate items, we run the lrem command. We then pop off the dwarf planet Pluto. And finally, we check the length of the Redis list, and we're down to 8. Here's one way to run this test, and you can see that it passes. Now let's look at the test redis set method. This adds the planets to a set instead of a list. We start by adding all elements of the list to the redis planets set. Next, we call the scard method to get the cardinality, or number of items in the set. Because sets can't have duplicate members, the cardinality of this set is 9. Adding the planets in the list to this set removed the duplicates, which is expected. Next, we fetch the members of the set, and we create a Python set to ensure that it has the same elements as the Redis set. Lastly, we drop Pluto from the set using the srem command. And here we run the test, and it passes. Before moving on, a quick reminder. In the previous two examples, we used the list command lrem and the set command smembers. Because these commands are O of n, they may be inefficient when used against high cardinality data structures. That is, data structures containing tens of thousands or more elements. When you're dealing with a lot of elements like this, you should use the scan family of commands. For example, for large sets, you should use scan over scard. Okay, the last data structure we'll look at is the Redis hash. You can see this example in the test redis hash method. We start by creating a Python dictionary containing some properties of the planet Earth. Here we store its diameter, the length of its day, the mean temperature, and the number of moons. And then we add them to a Redis hash with the hset method. You can pass multiple field value pairs to the hset method by passing in a dictionary for the mapping argument like we do here. Now we finish up the test by fetching a single Earth property using the hget command. Lastly, let's run and verify this test case. So, in this unit, you saw how to use Redis Pi to access and manipulate Redis lists, sets, and hashes. You also saw how these data structures map to Python types. We'll see later in the course how to work with more advanced types such as sorted sets and geographic structures. But we now have enough knowledge to get going on our app, and in the next unit, we'll learn how to write data access objects to do just that.